So this is all empty. It has big holes on the bottom. And when we want to go down, we put air from a scuba tank into here. This is a air shock, BF Goodrich air shock. It lifts this up, lets the air out, the water floods in, and the whole thing sinks. And when we want to bring it back up, we put air into this, which is a Bennett trim tab actuator that you'd see on many boats. It opens a quarter turn valve, takes compressed air out of this tank, blows it into here, pushes the water out, and up you come. So this is what's referred to as syntactic foam. Syntactic foam is foam that doesn't compress under pressure. So this will keep its size no matter how much pressure's on. So it's expensive. This is about $15,000 worth of foam. So on here, that's a mount for the laser scanner. We're actually using it for the CTD now. This will look a lot nicer when it has its clothes back on. This is a box. I believe this is for the cameras, and it has a pressure compensator. So this makes sure that the pressure in here is always about, right now it's set at about 5 psi above ambient. So if it's 6,000 psi outside, this will be 6,005, so that if it gets a crack, the oil comes out and the water doesn't necessarily come in. The control spheres we were talking about are here. These are glass. They're about 3/4 inch thick glass, and they're 2 halves. They're filled with oil, so that were they to crack, it won't have an implosion. Glass has a bad reputation. If you have a sphere this size that cracks at Titanic depth is something like 10 sticks of dynamite. It's a massive amount of energy. But when it has oil, it doesn't. So we got the aft dome here. This is another 3¼ inch thick titanium dome, bolted to another titanium piece glued to the carbon fiber. Carbon fiber is coated with rhino liner, which is sort of what the military uses. It stops water penetration at high pressure into the carbon fiber. These are the control lines. You can get back with the buoyancy bag, which you can see. You can see the bottom of it here. There's basically a bag, and that black high pressure tank back there feeds the 10,000 psi air into the bag. Well, 10,000 psi will barely fill the bag. It's about 2/3 full at Titanic depth. When you get to about 3,000 meters, it gets it totally full, and it's way more than you need on the surface. So that's one method of getting to the surface, but we typically weight the sub very heavily to get down. And we'll load 6 weights in there, and we'll drop 4 of them to get back to the surface. If that system failed, so you had a complete electrical failure and you can't activate those things, this is a hydraulic cylinder that goes into the cabin, and there's a hand pump, 10,000 psi hand pump. So all you gotta do is open a valve, and you pump this, and it pushes a pin, and this whole system drops off. So this, and all of this, and all the lead down here can be dropped in an absolute emergency, so you can get to the surface.
So what's the material of that?
It's acrylic, plexiglass.
Wow.
Yeah, and it is 7 inches thick. It weighs about 80 pounds. And when we go to the Titanic, it will squeeze in about 3/4 of an inch. It just deforms. The acrylic's great because it squeezes in, and before it cracks or fails, it starts to crackle. And so you get a huge warning if it's going to fail.